Today we're going to be talking about the first fundamental theorem of calculus. So you can expect this to be pretty important. In the video, I'm actually not going to go through the proof. You can take a look at it in the notes, and I'll include a link to a video with another proof of the fundamental theorem. But I'm just going to jump to the conclusion. So the fundamental theorem of calculus, this is on the second page of your notes. If capital F prime of x is equal to f of x, then the integral from a to b of little f of x dx is equal to capital F of b minus capital F of a. And again, there is a proof for this, but this is the fundamental theorem of calculus, that if you want to find the integral from a to b of a function, then you're going to take the antiderivative evaluated at b minus the antiderivative evaluated at a. So it's always the top number minus the bottom number. So let's do an example. We're going to use the fundamental theorem of calculus to find the exact value of 1 to 4 of x to the 1/2. So the first thing we're going to do is find the antiderivative, the indefinite integral of x to the 1/2. So we're going to add 1 to the exponent, so that's going to be x to the 3/2. So we're going to multiply by 2/3. And then we're going to evaluate this. Let's do a plus c from 1 to 4. So this is going to be 2/3 times 4 to the 3/2 plus c minus 2/3 times 1 to the 3/2 plus c. The c minus c's are always going to go away. So I'm never going to write that c again for a definite integral, meaning if there's numbers here, we don't have to do the c. If it's indefinite with no numbers, then we have to include the c. So this is going to be 2/3, 4 to the 3/2. If I do 4 to the 1/2, that's the square root, so it's 2 cubed. So this is 8. This is going to be minus 2/3. So we have 16/3 minus 2/3 is going to be 14/3. All right, so the definite integral from 0 to pi over 4 of secant squared is going to be the antiderivative of secant squared, which is going to be tangent theta evaluated from 0 to pi over 4. So we just put a straight line with those two numbers. So that's going to be tangent of pi over 4 minus tangent of 0. Tangent pi over 4 is 1. Tangent of 0 is 0. So this integral is 1. Okay, integral from 1 to 2 of 1 over x to the 6th. I find it easier for some of these just to rewrite it as just a power, so -6. So then this antiderivative is going to be, we're going to add 1 to the exponent, so that's -5, and divide that by -5, or multiply by 1/5, evaluated from 1 to 2. So this is going to be, I'm going to rewrite this as -1 over 5 x to the 5th, so that's going to be 2 to the 5th, minus a -1 over 5, 1 to the 5th. And you can muscle through all this work, but you're going to end up getting, and you can type it in the calculator too, 31 over 160. Okay, So start by finding the antiderivatives of each of these. Got x cubed over 3 minus 2x squared plus 7x. We're going to evaluate this from -3 to 0. So we're going to evaluate this at 0. These are all going to be 0. So I'm just going to say 0 minus. Then we've got -3 cubed over 3 minus 2 times -3 squared plus 7 times -3. The negatives, this is going to be negative, this is going to be negative, this is going to be negative. So when I subtract them, they're all going to be positive. So we're going to have a 27 over 3 is 9. 9 times 2 is 18. And 7 times 3 is 21. Like I said, they're all negative, but then they're the opposite, which gives me 48. Okay, integral from 0 to 1 of x minus secant x tangent x. Antiderivative of x is x squared over 2. Antiderivative of secant tangent is secant. Evaluated from 0 to 1. So this is going to be 1 squared over 2 minus secant of 1 minus 0 squared over 2 minus secant of 0. It's going to be 1/2 minus secant of 1. That's 0. Secant of 0, cosine of 0 is 1, so secant of 0 is 1, so we have minus a -1, which is going to be plus 1. 1 and 3/2, or 1 and -1/2. That's not a negative, equal. So we have 3/2 minus the secant of 1, and that's not enough value, we know, so we just leave it just like that. Okay, the next question, what is the distance traveled by a car from t equals 0 to t equals 3 if v of t is 40 minus t plus 1 to the 1/2? Okay, well, we did this geometrically the other day. This is going to be the rate times the time. So the velocity times the time. Well, the time is 0 to 3. 40 minus t plus 1 to the 1/2. So then we find the antiderivative. So that's going to be 40t minus, I'm going to leave a space here. This is going to be t plus 1. We're going to add 1 to the power, so to the 3/2, which means I'm going to multiply by the reciprocal here, 2/3, or divide by it. From 0 to 3. So this is going to be 40 times 3 minus 2/3, 3 plus 1, so 4 to the 3/2, minus 40 times 0 minus 2/3 times 1 to the 3/2. So we're going to have 124 to the 1/2 is 2. 2 cubed is 8. So this is going to be 16/3. That's going to be 0. We're going to have minus a -2/3. So when you get a common denominator and everything, this ends up being 346/3, which is approximately 115.333 feet away. Okay, the integral from 1 to 1 of x squared. So that's going to be x cubed over 3, evaluated from 1 to 1. So that's going to be 1 cubed over 3 minus 1 cubed over 3, which is 0. And that's always going to happen. And if you think about this geometrically, I'm going from 1 to 1. That means I have no width, which means the integral from a to a is always going to be 0. Okay, now we have the integral from 4 to 0 of x and 0 to 4 of x. So let's do this first one. So this is going to be x squared over 2. So we do the top minus the bottom. So this is going to be 0 squared over 2 minus 4 squared over 2. So we're going to have 0 minus 16 over 2. So this is going to be negative 8. This one's still going to be x squared over 2, but these are switched. So this is going to be 4 squared over 2 minus 0 squared over 2, which is going to be 8. So the relationship, if the bounds are switched, they are opposites. So the integral from a to b of f of x is equal to the opposite b to a of f of x. The graph shows f of x equals 19 minus x squared. Why is it an even function? Because it's symmetric to the y-axis. Okay, also f of negative x equals f of x. So it says to use the fundamental theorem to calculate the integral from negative 3 to 3 and the integral from 0 to 3. And explain why it would be twice. Well, just think about this. If I go from negative 3 to 3 versus 0 to 3, this distance is exactly the same. So we can do both of them. Let's do integral from 0 to 3 first. 19 minus x squared. So this is going to be 19x minus x cubed over 3, evaluated from 0 to 3. So that's going to be 19 times 3 minus 3 cubed over 3 minus 0, because when I plug 0 into those, they're both 0. So this ends up being 48. Okay, and I can do the math for the next one, negative 3 to 3, but you're just going to see it's going to be doubled. So this one, and you can look through the notes, but this one's just going to end up being 96. And it should make sense. Why is it twice? It's because the area is doubled. So you can, if you have an even function, then the integral from negative a to a is going to be equal to the double the integral from 0 to a. So it's something you may choose to rewrite, and rather than go from negative a to a, just do from 0 to a, because that makes your, sometimes, depending on the function, makes your work a little bit easier. Okay, x cubed is an odd function because it is symmetric to the origin. Also, f of negative x equals negative f of x. We're going to use the fundamental theorem to go from negative 4 to 4, but it should make sense geometrically that we should get an answer of 0, because this area and this area are going to cancel each other out. So this is going to be x to the 4th over 4, evaluated from negative 4 to 4. Okay, well this is going to be to the fourth power, this is going to be the fourth power, so whatever this number is, we're subtracting the same thing. So this is 0. The reason, again, because the positive area is equal to the negative area. Area equals negative area. So if we have an odd function, then the integral from negative a to a, and they have to match. If they don't match, then this doesn't work. But from negative a to a is 0. So in this problem at the bottom of the page, cosine is an even function, 10x cubed is odd, and tangent is odd. So from negative 1 to 1, that's going to be 0, and that's going to be 0. So I'm just going to have the integral from negative 1 to 1 of an even function, which I can go ahead and change as 2 times the integral from 0 to 1 of cosine of x. So that's going to be 2 times sine of x, evaluated from 0 to 1. So 2 sine of 1 minus 2 sine of 0. Sine of 0 is 0, so this is just going to end up being 2 sine of 1. Okay, we have two functions, f of x and g of x. We have the integral from negative 1 to 0 of f of x. We have the integral from negative 1 to 2 of f of x. We have the integral from negative 1 to 2 of g of x. So we're just going to apply some simple rules, and these will hopefully make pretty logical sense. So the integral from negative 1 to 0 of 8 times f of x, all we're going to do is multiply 8 times the integral from negative 1 to 0, which was 3. So that one's going to be 24. Here, negative 1 to 2 f of y dy, as long as those two are the same thing, then that's the same exact thing as the integral from negative 1 to 2 of f of x dx. It's just a different letter. The integral from 2 to 2 of g of x, always 0 if they're the same. The integral from 0 to 2 of f of x. Okay, well if I look here, I have the integral from negative 1 to 0 and the integral from negative 1 to 2. So what I'm going to do is I'm going to take this one and subtract from negative 1 to 0. So this is going to be negative 1 minus 3, which is going to be negative 4, because I know the area or the integral from negative 1 to 2 is negative 1, and I want to chop the negative 1 to 0 off to get from just 0 to 2. Negative 2 to negative 1 of g of x. We have negative 1 to 2. Well, if this is positive 2, these are switched, which makes this negative 2. Okay. The last one, we're going from negative 1 to 2 of f of x minus 2 g of x. So we're simply going to take these two guys and combine them. So this is going to be negative 1 minus 2 times 2. We get negative 5. Here, I'm going to break this down into two integrals. I'm going to have the integral from negative 1 to 2 of 3f of x minus the integral from negative 1 to 2 of 5. Okay, so that minus is that minus. This one is going to be 3 times negative 1 minus, this is going to be 5x evaluated from 2 to negative 1. So I'm just going to work sideways here. We've got negative 3 minus, this is going to be 5 times 2 minus 5 times negative 1. So this is going to be negative 3 minus 10 plus 5. So negative 3 minus 15 gives me a negative 18. The integral from negative 2 to 2 of the square root of x does not exist because the function doesn't exist from negative 2 to 0. It starts at 0, so it's undefined there. Okay, for the piecewise, if I want the integral from 0 to 3 of this function, part of it is this line, part of it is this line. So I'm going to have to break it up into two integrals. One from 0 to 2. The function that's represented from 0 to 2 is here. Then I'm going to have the integral from 2 to 3 of my other function. So I'm going to have a negative 1/2 x squared from 2 to 0 plus x squared plus x from 3 to 2. So this is going to be negative 1/2 2 squared minus 0 plus 3 squared plus 3 minus 2 squared plus 2. So I've got a 4 times 1/2, we get a negative 2. 9 plus 3 is 12. Minus 4 plus 2 is 6. So this ends up being 4. Okay, next one. We don't really have an antiderivative for absolute value. So this is going to be the absolute value moved over 3. And we're doing the integral from 1 to 5. You have two options here. And I'm going to choose the easier of the two options, but you can look in the notes for the harder version. The harder version would be to rewrite this as two integrals. One for x minus 3. This line here would be negative x plus 3. So you'd set up two integrals. One from 1 to 3 of this equation and 3 to 5 of this equation. I'm going to make my life easier, and I know what this graph looks like, and the integral is just the area, so I'm just going to do this geometrically and say this is 1/2 2 times 2 plus 1/2 2 times 2, which is going to be 2 plus 2 is 4. Or, like I said, you set up two different integrals and do it the long way. Our last problem, we want the integral from 0 to k of 2kx minus x squared equals 18. We are going to solve this equation for x. So let's first do the antiderivative. So the antiderivative of 2kx is going to be kx squared. K is just a constant. This is going to be minus x cubed over 3, evaluated from 0 to k, is equal to 18. So I'm going to plug k in. So we're going to have k times k squared minus k cubed over 3 minus, that's going to be 0 and that's going to be 0. So I'm just going to drop that, equals 18. So we have k cubed minus k cubed over 3 equals 18. So that means 2/3 k cubed equals 18. Which means k cubed, if I multiply by 3 and then divide by 2, is going to be 27. So k is 3. So that's how we do a definite integral.